Hey guys, Mr. T here. This is another video. This one is about the association between categorical variables and essentially two-way tables here. So we need to keep in mind what the idea of categorical variables are. Categorical variables are variables whose data is just named items, and those names or categories, which is why they're called categorical variables, those categories have no real hierarchy or relationship with each other. So, for example, if we said our categorical variable is hair color, well, the different categories are brown, black, blonde, red, etc. Those have no hierarchy. They have no relationship with each other. One's not bigger than the other, for example. So there's particular ways that we need to display this. So one method of showing how well associated two different categorical variables are is using a two-way table. A two-way table has one of the categorical variables forming columns on the table, and the other categorical variable forming the rows on the table. Cells at the intersection of categories contain collected data. So let's show that with an example. So Sophie wants to test whether students' gender is associated with their grades. She collects grade data from 70 students in her year level. 50 boys surveyed, 15 had A's, 21 B's, 14 C's, 20 girls were surveyed, 10 had A's, 8 scored B's, 2 scored C's. Now, obviously gender is a categorical variable with the categories male and female. I'm not going to bother getting into an argument about any other different genders there being. There's biology, okay? Deal with it. Grade is a categorical variable with the categories A, B, and C. No argument about that one. So this data can be displayed in a two-way table as below. So there's no rule, because it's not really an experiment, and we don't have an X and Y axis. It doesn't really matter which you're making, rows and columns. I'm just deciding to have grade being the columns and gender being the rows. So grade and then gender. So what do we have? Boys, girls, and so start forming this table. It's the straightest line in the world. Here we go. A, B, C. Probably should have put that gender title there. Alright, 50 boys were surveyed, 15 scored A's. So, the intersection between A, category, and the boys category is here. And that will be filled in with 15, because 15 boys scored A's, 21 boys scored B's, 14 scored C's, 20 girls were surveyed, 10 scored A's, 8 scored B's, 2 scored C's. Alright, that's essentially the two-way table. Sometimes it's useful to total them as well. It's useful to total them because of the next step that we will discuss, which is frequency tables. Having the totals already worked out makes that process of finding the relative frequency a bit easier. So, how many students were there surveyed in total? There were 70 of them, so that's going to be the total of the rows total and the columns totals. Now, the columns totals, if we look down, this total is going to be the total of people that scored A's, regardless if they're boys or girls. So that's going to be 25. The next column total is going to be the total B's scored, so that's going to be 29. And next is 16 C's scored, regardless boy or girl. The row totals are going to tell you the total number of boys surveyed, which was 50 anyway. We could have found that by adding these three numbers together. in the columns, but we don't need to. And the number of girls was 20, and as you can see, these numbers should add up to 70 going across and 70 going down. So there you have it, two-way table displaying categorical data. Looking at the data in this case, it looks like boys. There's more A's with boys. There's more B's with boys. There's more. Alright, so if you were sort of a pleb and you just wanted to look at this data as it stands, therefore appears that boys get better grades. Why? More A's, more B's, more C's. And that's a silly person's argument, because obviously only 20 girls were surveyed. And that brings us to the idea of taking the next step, which is two-way frequency tables and actually finding the relative frequency of these numbers, of the data. Obviously, looking at the raw numbers in the two-way table above, it may seem that boys are more associated with higher grades. They've just got more of these A's. 15 A's versus 10 A's with girls, but that ignores the fact that less girls were surveyed in the first place. Okay? Don't let people fool you with statistics. You can make statistics say whatever the hell you want. If you do it properly, then you can get around that. And usually properly means using percentages, which is what frequency tables is about. Two-way tables are more useful when they display the relative frequency of results compared to the total, i.e. the percentage of the total the data represents. This accounts for the difference in number of girls and boys surveyed. So I would be expecting you, if you were to ever take a survey, to take the extra step and do do frequency calculations, because it's more meaningful if you have unfair survey amounts. So create a two-way frequency table of the previous example, showing the percent of each gender that scored a particular grade. So it's important to note that we want to know the percentage of each gender that scored a particular grade, because that tells you what you would be totaling. So once again, gender, forming the rows, grade, forming the columns, boys, girls, A, B, C, here we go. So here we are going to do some extra little calculations to work out the frequency. We want to know the percentage of each gender that scored a particular grade. So what we would be comparing to is the total number of girls that scored a particular grade and boys that scored a particular grade. So 10 girls scored A's, but compared to their total of 20, that was 50%. So I'll do it in red. 10 over 20 times by 100%. It's going to be 50% of all girls scored A's. Let's do the same thing with boys, showing the percentage of each gender that scored a particular grade. So we're looking at A's for boys. 15 boys out of 50 scored A's. 15 over 50 times by 100%. That tells you that 30% of boys scored A's. So now we're going to repeat the process for all of the other grade levels. 21 boys out of 50 scored B's. 8 girls out of 20 scored B's. Red. 21 out of 50 times by 100%. 8 out of 20 times by 100%. Those come to 42% and 40%. Lastly, 14 out of 50 got C's for boys, 2 out of 20 got C's for girls. 14 out of 50 times by 100%, 2 out of 20, 100%. That comes to 28% of boys got C's, 10% of girls got C's. And then it may be of interest to see what percentage of people overall got certain grades, ignoring their gender. So if we look back, 25 people originally got A's out of 70. 25 over 70 times by 100%. Next, 29 out of 70 scored B's. 29 out of 70. And lastly, number of people that scored C's. 16 out of 70 scored C's. In red, 16 out of 70 scored C's. What do those come to combined? 35.7%, 41.4%, and 22.9%. So here we can see, now that we've found relative frequencies, actually the argument is a bit different. Of all genders surveyed, girls had much higher percentage at the A grade band. Half of the girls got A's, whereas only less than a third of boys got A's. There was more of a lean towards boys scoring B's, but it was pretty similar. More boys got C's than girls did by almost 3 times. So really, if you're looking at this argument here and using the frequency table, there's more to it. Because you surveyed so many less girls than boys, the percentage of girls that actually scored high was much higher than with the boys. So really, there's a stronger association with high grades with girls than with boys. And so that shows the importance of looking further than the straight raw data and actually generating a frequency table, a two-way frequency table, to deal with the difference in surveyed amounts. So hopefully that helps you, and see you in the next video.